Hello, Daniel Rio. Thank you for coming to our series of mining interviews, for
Thank you.
participating. Today we're going to talk about density measurement and control in the thickening process. First of all, it would be nice if you can give a little introduction about yourself.
Sure. My name is Dan, and I'm an instrumentation technologist in a nickel mining company in Canada. And I'm very lucky to have worked with some very talented people in both the pulp and paper and the mining industries on some really challenging controls. So today I'm going to talk about some of my experiences with installing and controlling density gauges, and we're going to use thickener underflow as an example.
Okay, great. So what would be the first step for implementing the density measurement and control?
Well, the first step is the actual installation, and that's pretty much the most important one. So picking a proper location, setting up a proper orientation of the meter, depending on the technology used, proper pipe sizing. They're all key components in a proper installation so that it works properly and accurately. And they'll be very difficult to compensate for or correct after the fact, so it's important to get it done and installed correctly right away.
So in the first time you need to have it completely
yeah,
well
usually
done.
the price becomes a bit prohibitive, right, to correcting a situation, so you're left attempting to compensate, and it's usually a poor result. So it's best when you're spending the money to do it correctly the first time.
Yeah, that seems to be fair. So what if the instrument is not installed in the right way? Would the measurement result deviate from the real density value?
Yeah, it definitely can. So we're talking about slurries. Settling is always kind of a challenge that we have, unless you have extremely high pipe velocities. And so that settling will tend to build up in front of or within the measurement zone and stack into the measurement result and cause deviations. And that settling is usually very inconsistent. So these are problems that you want to stay completely clear of. You want to measure that actual density regardless of any kind of settling effect. So you want to position your meter in the best way possible.
Yeah, so you choose the best location for it. So you talked about the orientation of the instrument in regard to the pipe. But what about the pipe itself? Does the orientation of the pipe also matter?
Yes, it does. Yeah. So typically we would want to use a vertical installation because, again, settling in a vertical pipe is not really possible, right? Unless it's a really, really bad design, completely oversized. You could have surging density, basically stuff slowing down and then raining, if you want to picture that in your mind. The heavy material would start to settle out and crash within a vertical section of pipe. But that requires a lot of like gross oversizing of the pipe, but it does happen. But basically a vertical orientation is best because the solution will not have anywhere to settle. So that is your best approach.
So you always make sure that settling cannot happen, so your instrument is fine in that location. Yeah.